Hi everyone. Okay, so let's get started. So we are going to start a new topic today, which is covariance, right? Okay. It is just like a variance, but there is a little difference, and we will see that what is this covariance, why we even need it. Okay. So let's just study this covariance completely. So before I start covariance, let's just review variance. Okay, what was the variance, and then we will start this covariance. So do you remember variance? Variance was one of the quantity that we have studied. But now let's just see again what was the variance. So I have taken the same slides that I have taken in the variance. So variance is one number just like expectation or just like mean. Okay. It is a way to summarize the data. Variance mean was the one way to summarize the data, and variance is just one another way to summarize the data. Together, they serve a very good summary of the data. So variance is basically average distance from mean. Maybe you remember a little bit, but let's just see it again. Okay. For example, let's suppose this is some toy data set or example one. Okay. Let's suppose this is example one. And let's suppose this is example two. Okay. Suppose these are the two examples that I have here. Now, suppose this is example one. Okay. This was the example one. And this is example two. Suppose in both of these examples, I want to calculate variance of both of these data. Okay. So if you want to calculate the variance for the example one, then it seems like, let's suppose it is 0, this distance is 5, this distance is 5. So variance is basically the square distance, sum of the square distance from the mean, okay, average of the square distance from the mean. So mean is 0, these are the 3 points, and here, let's suppose it is -5, it is 5, and it is 0. So -5 plus 0 plus 5 divided by 3, it is 0, right? Mean is 0. So that's why distance of this from mean is 5, distance of this from mean is 0, distance of this from mean is 5, right? So that's why the variance is coming out to be 50 by 3. So which means variance is actually a way to tell you that how much spread the data is, right? So from this formula, you are able to understand variance was expectation of, if you remember, x minus expectation of x whole square. How many of you remember this formula? This was the one of the formula for the variance. There is a simpler formula also, but yes, this is one of the formula. How many of you remember? Tell me, right? Okay. So there is another formula that we will talk about. We can simplify this, and then there is another formula that we can talk about. But what I'm saying here is that variance is a quantity. Okay, if you understand it, by the formula, then you can say variance is a quantity which is average of the distance of x from the mean, right? Square distance basically. So basically, you will be taking the distance of this from mean, distance of this from mean, distance of this point, right? These are the 3 points. You take the square distance and then you take the average. It will be the variance. Similarly, here the variance is 2 by 3. Here the variance is 50 by 3. So in which example the variance is more? In example 1 or example 2? This is the example 1. Let's suppose. This is suppose example 2. In which example the variance is more? Obviously on the example one, right? This is 50 by 3, which is obviously more quantity. Why it is more? Because you understand intuitively, because that data is far spread from the mean, right? From this mean, data is spread, right? Data is far spread compared to this, right? Compared to this, data is less spread from the mean. If data is far spread, then variance is more. If data is less spread, then variance is high. So variance is high because because data is far spread from center, right? Or from mean. Okay. So this is the variance. I hope you remember, right? So for example, here, if you want to find out the variance, then there will be some quantity. Let's suppose these are the 3 points. Okay. Only 3 points are there. Then you can easily find out the variance, right? So what will the variance? 1 plus 2 plus 6. So first of all, you find out the mean, which is the expectation of x. Okay. So 1 plus 2 plus 6 divided by 3. This will be the mean, which means 3. 3 is the mean. Okay, this is the center of mass or the mean. And then from here, you need to find out the square distance. So this is 2 square plus 1 square plus 3 square divided by 3. Because this is 2 far away, this is 1 far away, this is 3 far away, right? So this will be 4 plus 1 plus 9 divided by 3. This will be 13 plus 4, no, 1 is 14, right? Divided by 3. So 14 by 3 is your variance here. Understood? Okay. This was just a review of variance. So this was the formula. And now, if they have given you the PMF instead of giving you the general data, instead of giving you this kind of data, this is called a sample data. If they give you the PMF, then can you find out the variance? Then also you can use the formula and can find out the variance, right? So basically, let me just tell you. Oh, sorry. So here I think I have, yeah. So basically for the variance, we have these two formulas, right? And both of these formulas are same. How many of you remember this? For the variance, we have these two formulas, right? And which means this is the main formula, and this is also the equivalent formula, which means if you just derive, or if you just simplify, sorry, if you just simplify, then you will be getting this formula, right? If you just simplify this, then you will be getting this formula. Okay. Now, if they give you the PMF directly, then also you can find out the expectation of x and expectation of x square, these things, right? Okay. So given the PMF or the PDF, whatever they give you, right? You can find out the variance, maybe the discrete random variable, maybe the continuous random variable, or maybe they give you the data in this format, which means they say that, okay, the data is like this, the values are like this. They just give you the values, okay? These are the values, find out the variance. Okay. For example, x is, let's suppose, 2, and then 5, then 9. Find out the variance. Can you find out the variance given the sample data itself? Right? So you can find out the variance in all of these cases, I guess, right? Okay. If sample data is given, no probability, right? If let's suppose PMF is given, if let's suppose PDF is given, can you find out the variance using this formula? I think yes, right? Okay. I hope that is fine to all of you, right? You can use this formula for in these two cases, and then to find out the variance from the sample data, you can just use the naive approach. Okay. Now, now let's just move to the covariance, which is the topic of today. So first, let's just see that why we even need this covariance, right? I mean, variance was good enough. It was conveying something. For example, it was conveying like that. In this case, the variance is more. In this case, variance is less. Okay, so it was conveying something. So variance was good enough, but we also need one more quantity, covariance, if we want to check how two random variable or how two features are varying with each other when you increase or decrease one of the feature. So basically, one way we can access the relationship between two random variable is the covariance. Okay. So the formula of covariance looks like this. Earlier it was the variance, and instead of this, okay, instead of this, it was a square here. Almost same, but here now you have the different quantity. Let's just first try to understand the intuitive meaning of this quantity. Okay. So why we define this covariance? Can anyone tell me? Because we want to assess the relationship between two random variables, right? Okay. This was the only reason. We want to check that how two random variables are working with each other. Uh, okay. Maybe let me just give you the example. For example, let's suppose this is x, this is y, right? Suppose this is 1, then this is let's suppose 2, 3, 4. Okay, this is 5, this is 9, this is 12, this is 14. Okay, suppose something like this. Tell me, if x is increasing, is y increasing? Whenever you go, okay, whenever you increase this x, is y increasing? Yes, right? So here in this case, okay, just an example, this is just an example where if x is increasing, okay, then y is increasing, isn't it? But I want to not just look at it. Okay, see, you told me how, by just looking at it, but I want to define a mathematical quantity that can tell me this thing. Okay, that if x is increasing, then y is increasing. I want to define some mathematical quantity. Is this understood, that why we need covariance? So basically, here you have observed that, okay, if x is increasing, y is increasing, that's fine. But maybe if there are let's suppose thousands of entries, if there are lacks of entries, then you can't just observe, right? You need some mathematical way to answer this question. So the mathematical way to answer this question is covariance. Now, using this quantity, we will be answering this question that, okay, if x is increasing, then y is increasing or decreasing, like that, right? Okay. So you understood that why we need covariance, right? Now, let's just understand that what is the meaning of this formula. See, this is the average of something, right? This is basically E means average or the expectation, right? This is average of something. What is the something? See here, this is x minus ex. So what I'm saying here is that see, the idea here is that if covariance is greater than 0, okay, then I will say that it is a positive correlation, in the sense if x is increasing, then y will increase. Okay. This is my idea. Basically, I want to say if it is greater than 0, then whenever x is increasing, then y is also increasing. Okay. So see here that let's suppose there is some x. Okay. Maybe let's suppose you pick any x. Let's suppose here you pick 1. There is some x, and you pick the corresponding y, which is, let's suppose, 5. Okay. This is 1 minus, can I write it mu 1? Is this fine? Mu x. Mu means generally mean. Okay. Or if you want, I can write expectation. And this is 5 minus expectation of y. And like that, this is just one quantity. Okay. This is multiple of one quantity plus what it will be there? 2 minus ex into 9 minus ey. Is this okay to everyone? Like that, you need to basically find the average. Okay. But let's just focus on one of the quantity, 1 minus ex into 5 minus ey. Tell me what is the ex? Ex is some average, right? Maybe that average will be 4 plus 3, 7, plus 2, 9, and 1, 10, divided by 2. Sorry, divided by 4. 10 divided by 4, 2.5, right? So average is something somewhere here. 2.5. Okay. Now, let's just see that what is this average of this y. So can you tell me the average of y? 28 plus 12, 40 divided by 4, 10, right? So I think it is 10. Okay. So this is 10. 10 is here. Okay. So ex is basically 2.5 into 5 minus 10. This is one of the quantity. Is this fine to everyone? The one of the quantity is fine? Or there is any problem in this? Let me know. Based on the formula, this one of the quantity I have written, right? This quantity, you don't tell me the exact answer, but tell me this will be negative or positive. This first quantity, I think this will be negative, and this quantity, negative. So negative into negative is actually positive, isn't it? So basically, this whole quantity, the first term is positive. Similarly, if you find the second term, okay, which will be 2 minus 2.5, 2 minus 2.5 into 9 minus 10. The second term is also, this is negative, this is negative. So second term overall is positive. Similarly, it will be 3 minus 2.5, 12 minus 10. So I think all the terms are positive here. Is this fine or should I do it? See what I'm saying. First term was something like this, right? 2.5, 1 minus 2.5. So the first term you write 1 minus 2.5, which is average, into 5 minus 10. Plus second term is 2 minus average, 2 minus what is average? 2.5 into 9 minus what is average? I think 10, right? Plus 3 minus 2.5 into 12 minus 10 plus 4 minus 2.5 into 14 minus 10. Let me know if these terms are fine, right? Divide by how much? Divide by 4, right? Because we need to find the average. Okay, great. Now all of this term is positive, right? This is negative, negative, but negative into negative, positive. I will tell you why. I mean, what is the significance of this? Okay, all of these terms are positive, so ultimately it is coming out to be positive only, right? It's just fine to everyone that this is positive quantity. I mean, for this particular data set, the covariance that we have calculated, I'm not calculating the exact answer of the covariance, but you can do it if you want to. But the covariance is greater than 0. And my objective was like this: if 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 covariance is greater than 0, then I can say x is increasing, then y is increasing. Okay, I mean they're positively covarying with each other, which means if x is increasing, then y is also increasing. So why I was able to say this? Because see here, this is basically saying if x is lower than the average, if x is lower than its own average, and at the same time if y is also lower than its own average, right? So basically what they are saying, they are finding out the average of x, okay, which is 2.5. They're finding out the average of y, which is 10. So they are saying at the same time, they are saying if some number, if this is lower than the average, my own average, at the same time the corresponding number is lower than its average, right? Similarly, this 2 is lower than, 9 is lower than, if it is greater than the average, then it is also greater than the average, which means what is happening here, if this is positive, this quantity is positive, then this is also positive. If this is negative, then this is negative. In that case, the covariance will always be positive because all the quantities are positive. See, what I'm trying to say here, let me just tell you. See, suppose mu x means expectation of x, okay? So suppose x is greater than mu x, okay, or expectation f. Similar, at the same time, y is also above its average. In that case, the product will be greater than 0. It is very simple, right? I mean, positive, this is like positive quantity into positive quantity will be positive quantity only, right? Here, if both are less than, if I'm, let's suppose as a x I am below than my average, then at the same time if y is also lower than my the average of y, in that case it is good. So these are the positive cases. But suppose I'm lower than my average, but y is greater than my average. For example, let's take an example here. Okay, just a second. Okay. So this is, let's suppose, positive, this is positive, then this is greater than 0. Okay. So for example, let's take this example. Let's suppose this is 1, 2, 3, 4 only. But this is x. But in that case, okay, let's suppose I'm flipping the y. I mean, you just consider this is another data. Y was I have taken 5, 9, 12, 14, right? I have taken 5, 9, 12, 14. But now let me take something else. See here, I have taken 5, 9, 12, 14. So I'm just taking 12, oh sorry, 14, 12, 9, 5. Okay, just for example. Okay, this time let's just take this. Average remains same, right? Obviously, I haven't done anything to the average. Average here also 10, earlier was also 10. Is this fine to everyone? Average remains same, average 10, average here 2.5, right? 2.5. Now you tell me if this is lower than the average, at the same time this is greater or lower than the average? Tell me. This 14 is greater than its average or lower? So it is greater. So this quantity, this I'm lower, this is greater. Oh, mismatch, right? So this first will contribute something negative. If this is mismatch, it will contribute negative. What about this? If I'm lower, this is again greater. Oh, mismatch, negative. This greater, but this is lower. Oh, mismatch, negative. This greater, this lower. Oh, mismatch, negative. So here all the terms are negative. So finally the answer will also be the negative, which means if x is increasing, tell me y is increasing or decreasing? On average, y is decreasing, right? So this is how this variance, oh sorry, the covariance is working. This is little bit intuition of about the covariance. Okay, over the time you will get to understand more. But is this intuition around the sample data, is this fine? What I'm trying to convey with the covariance? Okay, this quantity is telling you that if I'm lower than the average, and at the same time you are also lower than the average, that's best. I mean, that's good. I mean, it means that both are at the same time both are lower, or at the same time both are greater. In that case, it is a positive on average if this happens. But sometimes it may so happen that, let's suppose it is 1, 2, 3, 4, 5, 6 only. Okay, suppose this is, let's suppose 7, 9, and then maybe for one data maybe it is decreasing. Okay, maybe 8 or something. Okay, it doesn't matter. See, increasing, but suddenly decrease. Okay, but here let's suppose again increasing. Okay, just for one or two outliers. Okay, where it is showing some other behavior. The on average actually y is increasing, isn't it? If X is increasing, then Y is increasing or decreasing? On average. On average, it is increasing only. Okay, just one outlier, it won't be contributing much. Okay, there will be a negative covariance, I mean negative quantity in the covariance, but that's fine. Okay, this will be manageable. I mean other quantities will be positive, so they will just cancel. I mean they will just reduce the effect of this. Okay, I hope you understood. So this is the meaning of covariance, that if I am lower than the average, at the same time you are lower than the average, then it's great. Okay, and on an average, if this happens, okay, then the covariance is positive. Otherwise, the covariance is negative. Okay, so this measures the tendency of two random variable to move together. If they tend to move in similar directions, the covariance is positive. If they tend to move in opposite directions, the covariance is negative. In one sense, it is natural generalization of variance to the bivariate case. Bivariate means if there are two random variables. Okay. So let's see some example. Suppose this is the data. Okay. Let's suppose I'm plotting the data and I have observed. Let's suppose if X is this, then Y is this. Um, for example, let's just take it as a weight and height. Okay. Let's just take it as a weight. Let's just take it as a height. Okay. So suppose if is increasing, okay, in general, it is like assume that, okay, weight might also increase because taller people have the more capacity to carry more weight, probably. Okay, suppose this is the data of some height and weight, or maybe some other data you can assume. Okay, maybe okay, maybe the other data what uh, you want to have. Okay, maybe you can say it is number of ice creams. Okay, this on the x-axis. Let's suppose temperature and there is a number of ice creams, which means if temperature is increasing, then number of ice creams consumed by the citizens, okay, or number of ice creams sale on a particular shop is increasing or something like that, right? It makes sense. If temperature is increasing, maybe the ice cream sale is increasing. Okay, so just some data I'm taking. Is this fine? That what is this graph? Some data, right? Some data. It could be anything. Maybe height, weight, maybe temperature, number of ice cream sale, or some data, right? Now I want to check the covariance of these two, which means I want to check whether if temperature increases, actually it is just a plot that I have done, right? But let's suppose I want to mathematically justify, okay, whether the temperature and ice cream are positively co-varying or negatively co-varying, which means if or there is no relation at all, which means temperature has nothing to do with the number of ice cream sale. So suppose I want to check this, then what I can do? I can just calculate the covariance. How? If you remember the formula, then first I need to calculate. This is basically x minus ex into y minus ey, right? First I need to calculate ex and then ey. So let's just calculate ex. Ex means if you take for all the x, if you take the average, it is supposed coming out to be 4.8. Okay. Is this fine? Is this visible, by the way? This ex. I hope that's visible, right? Okay. So suppose this is coming out to be 4.8. And now let's suppose you do EY. EY means the average of all the Y values. Then what is the answer you're getting? Suppose you're getting 9.4. This is the first step. But you want to calculate the covariance. Okay. But you want to calculate covariance. So covariance is some quantity which says that x minus, okay, for example, I take 1 point here. You need to take all the points. I'm just showing you for 1 point. For example, this is the point. Okay, 1 point you have taken, right? Suppose this is 1 point, one of the point. Then for suppose x is this and y is this. Then what you will do? You will find out this quantity x minus ex into y minus ey. Suppose this is 9.7. And then you need to do it for all of the quantity. So basically, this x minus ex is coming out to be 3.1, right? Which means I'm above average, that to 3.1. You are also above average. That's great. Okay. So both are above average. Okay. So if I think this is basically ex, this is ey. So let's take some x which are lower than ex, which means if this is quantity is ex, some x which are lower than ex, right? So maybe somewhere in this area, right? Then only few people, okay, only few people here are such that if their ex, I mean for these point, they're lower than their x average, but they're above than their y average, but there are only few point. Will it impact my covariance? What do you think? There are only few outliers. See, there are only few outliers which are saying these are the type of outliers I can say. See, these are the type of outliers I can say that are lower than their x average, right? Lower than x average, but greater than y average, right? But these are the points which are greater than. Similarly, for these points, they're greater than x average, they're greater than ex. Okay, because ex is this, then they're greater than ex, whatever on the x-axis here, it will be greater. And they're lower than, okay, so they're greater than ex and lower than ey. But there are a handful of the points, I think, right? There are very less points. Okay, most of the points are basically saying that, okay, both are at the same time, both are lower than ex and ey. At the same time, both are greater than ex and ey, right? So these points actually won't matter. Finally, the covariance of this particular data set will be positive only. Okay. So let's just see that why we need this covariance. I mean, one of the motivation I have given you, but let's just rephrase this motivation. Can't we just work with the variance? Let's just see. Suppose I give you these two data points. Okay, these two sample data or these two data sets. Suppose that these are the two different data set. X and Y are like this. Okay. Here, let's suppose for the first data set, I calculated few quantities. Suppose I calculate expectation, which means average of all the x, which means whatever this x, you just take the average of all the x values, average of all the y values. Suppose I take the average of all the x or average of all the y. I calculate the variance of only x. I calculate the variance of only y, variance along the x-axis, variance along the y-axis. Okay, suppose I do this. After all of this exercise, for the let's suppose data set 1, I'm getting these quantities. Okay. Okay. Is this okay? Now suppose, okay, by the way, can you calculate these quantities? Do you think it will be very hard? Calculating the expectation given maybe PMF, given maybe PDF or maybe the sample data. Do you think this calculation will be hard? I don't think, right? You can do it. Okay. Anyway, we will be doing example. Don't worry. We will be doing example where we will be calculating these quantities only. Okay. We will be doing example where we will be calculating these quantities only. Don't worry. So this quantity, this quantity. So we will be calculating all of this. Okay. But I'm just saying that you can do it. But anyway, we are actually having the examples on this slide. Okay. Suppose we calculated some quantities for the first data set. Now, similarly, we calculated the same quantities for the second data set. Okay. Surprisingly, all of these quantities are same. See, if you remember this particular motivation, these are the two data set, right? Which we have taken earlier. These are the two data set. For first data set, variance was higher. For the second data set, variance was, sorry, for the example 1, variance was higher. For the example 2, variance was lower. Is this okay? Now suppose see, this was the example here. Here, I was saying basically the variance that we have calculated is actually telling me the difference between the first data set and the second data set, isn't it? Which means the variance, see, in both the cases, tell me the mean. In this case, what is the mean? If these are the three data points, I think this is +1, this is -1, this is 0. I think mean is 0, right? So expectation of x is 0 here. Can you tell me expectation of x in example 1? It is 0 here also, okay? -5 + 0 + 5. It is 0 basically. So mean in both the cases is 0, but the variance was different. So with this variance, I was able to infer something regarding the data. I was able to say that, oh, Since the variance is different, most probably this data is far spread. This data is less spread, isn't it? Mean is same. Okay, that's fine. So mean was not able to convey anything, but variance helped me here. Okay, you are understanding? So here I can say the variance has helped me, right, to understand the data. So variance has helped me to. Is this fine to everyone? Okay. To differentiate actually in both the data, right? Understand means to differentiate basically. Mean is same in both cases. Okay. Now, given this, let's suppose I have some other data set. Okay. It was the 1D data set. Now let's suppose I have 2D data set. Okay. 1D data set example could be like for practical users, I can say that for example, number of sales in ice cream only. Okay, I mean you don't have the temperature as another feature. Okay, number of sales, number of ice cream sales basically. For example, for day one it was something, for day two it was something like that, right? So it is just one feature, okay, or one random variable. Now suppose I have two random variables. Okay, so I have this data. Now suppose I calculated these quantity for the data one and data two, and it is seeming that both of these quantities, okay, both of these data set have all of these quantities just same. So tell me, is variance helping me? Is variance of x helping me? No. Variance of x will tell me that how much data is spread along the x, which means on the x-axis, how much it is spread. So here it is seems like on the x-axis in both the cases it is spread same. Okay. On the y-axis, how much it is spread? On the y-axis, basically, if you just project all of the data on the y-axis, then you will see this line, right? So on the y-axis, it also seems like it is equally well spread. Okay. So mean same, everything is same. But is the data same? Is the data same? See here, everything is same, still the data is different, right? So that is why we need something else which can convey me that these data are different, right? We need one more quantity that can differentiate the data, isn't it? We need one more quantity that can differentiate the data, right? Okay. So what is this quantity? That quantity is called covariance. Okay. Here we will be seeing that covariance in both the cases is different. Okay. We will be seeing that covariance here is zero. Here the covariance is actually greater than one. Sorry, greater than zero. Which means here it is saying that both are positively correlated, but here there is no correlation at all. Okay. So the covariance here it is zero, and here it will be greater than zero. So the covariance is something which can differentiate actually, right? So even though all of these parameters got failed, but covariance is here to help us. So that's why we need covariance. So you know how to calculate these quantities, right? Okay. By the way, the covariance, we have seen this. See, we have already seen this formula, but now we are having one more formula for covariance. Let me tell you that formula. So this formula seems like this. Okay. You can simplify this. It's a very easy simplification. Do you want to try this? Okay, let's just try this. Okay, how to go from here to here. This is easy simplification. You can just try it. I will also try, but let's suppose I did it. Okay, or we did it. Then you know that how to calculate this quantity, how to calculate this quantity. This quantity you can easily calculate using something called as what rule? Expectation of function of random variable. What is that rule? Lotus. How many of you remember this name? Law of the unconscious substitution, something like that. Okay. So we can calculate this using Lotus. Okay. Now let's just first verify that how to go from here to here. Okay. I mean, this is how we have defined the covariance, but what is this quantity? Let's just see. It is actually easy. Okay. Very easy to go from here to here. Let's just see. So suppose this is given. Now our end goal to get, sorry, I think, yeah, this was the quantity. So suppose we are given this. Okay. And our end goal is to check whether this is equal to this quantity or not. Okay. Do you want to try this? Just let me know if you want to try for just a minute. So let me just give you a hint. Okay. This is expectation of, okay, expectation of, okay, Ajay is saying he has got it. Okay, great. So this is some quantity you can multiply, this inside, this is xy minus x into ey. Okay. Let me write it ey only, or if you want, I can write it fully ey minus y into ex, plus ex into ey. How many of you understood this expansion? It is just a multiplication, okay? Just an inner multiplication. How many of you understood? I think all of you, right? Okay, great. Now just apply the linearity. Okay, so it is e expectation of xy minus this is expectation of x into ey minus this is expectation of y into ex plus this is expectation of ex into ey. Now given this, now you should be able to get this. Just try it for 1 minute. Okay, just let me know. So I think most of you guys have got it. So this is expectation of xy. This is expectation of some random variable. Okay, same to same. And then this is a constant, right? Expectation of a random variable is a constant. So you can take this constant outside. Okay, into expectation of x. Okay, so this quantity is expectation of x only. How? Because you have taken this. This is a constant. Okay, you have taken this outside. Minus similarly, you take this constant outside. Okay, this is a constant which you have taken outside, plus this whole thing is a constant. So constant expectation is just a constant. So expectation of x into expectation of y. Uh, okay, yeah. So I think one of this will get cancelled out, right? This one of this will get cancelled out with this, and this is just expectation of x into expectation of y, and this is the quantity that we were aiming for. Understood? Okay, great. Now, yeah, this is okay. Now let's just see how to find the covariance for this particular given sample data. Okay. So what is the formula of covariance? Just to revise you, this is the formula. Expectation of xy minus expectation of x into expectation of y. Okay. Either you do this or you can do this. Okay. Anything is fine. So which means you can say that these are the two formulas. Based on your convenience, you can do anything. Okay. So if you want to find out the covariance of this given data set, Then maybe here the xy is, you need to calculate the xy explicitly. So let's just do it with this first formula. Okay. So which means let's see how to find out the covariance using the first formula. So which is x minus ex. So let's just find out the expectation of this. What is the average of this? 2 plus 3, 5, 9, 10, 14, 15, 16, 16 and 3, 19 and 1, 20, right? So 1, 2, 3, 4, 5, 6, 7, 8 points are there. So it is 20 by 8. Similarly, what is this average? 13 plus 5, 18, 18 plus 8, 18 plus 8, 26, 20 plus 26 plus 8 plus 6. Let me just do it. 26 plus 8 plus 13 plus 5, 52 divided by 8. Okay. So this is 52 divided by 8. Now, let's suppose these averages we have got, right? Okay. Maybe you can make one more column if you want to. Let me take one more column, x minus mu x, one more column, y minus mu y. Okay. So you can subtract x minus mu x and then take average of these. Okay. Take average of these and then multiply. Sorry, this is x minus mu x. Yeah. So x minus mu x you will be doing. Okay. Then let's just have one more column. Maybe you can multiply. Okay. You don't need to take these individual averages. Then you can multiply this with S. This is basically the multiplication of these two quantities. Let's suppose this quantity is maybe P and then this is Q. So it is PQ, right? Then you need to take the average of this. So basically these two will get multiplied and then average of this. So you can do this, right? I don't have the answer on the slide, but you can just try it out. Okay. So this is when the sample data is given. But let's suppose they give you, instead of a sample data, they give you some distribution. Okay. Maybe using PMF, using PDF doesn't matter. I mean, continuous discrete doesn't matter. We can find out all of these quantities. Okay. Maybe I will be using this formula here. Okay. If they give you PMF, then maybe using the PMF and using the Lotus rule, we can find out these quantities. Let's just see. Let's just see. Okay. So suppose they ask you to find out covariance between x and y, and they give you something like this, right? They give you something like this. Then we need to actually find out. We need to actually find out the expectation of xy and expectation of x and expectation of y. So these three quantities we need to find out, right? So how to find out the expectation of x? See, this is a PMF that they have given, and which is a joint PMF, uh, which means mathematically this is a probability of x being 0, comma y being 0, right? Similarly, this is a probability that x being 0 and y being 1. Now, if you want to find out the covariance, then you need to find out the expectation of x first, which will be, if the individual PMF is given, then this is like this, right? Okay. First, you can find out the individual PMF. That's not an issue, but you can directly find out using the Lotus rule, which means, so this could be the any function of xy, and this is probability of xy basically. Okay. This is for any function, which means, I think you remember from the last class, you in the joint distribution also we were applying the Lotus rule. So what is the Lotus rule? Even for the joint it works. So expectation of any random variable which is a function of x and y will be, if it is discrete, then in that case it will be all the possible values of x, all the possible values of y, gxy, okay, into the joint probability. Okay. If it is continuous case, in case of contiguous, the same thing, right? The same thing, gxy. And here it will be the PDF. Maybe let me write f. Okay, it will be the PDF. Is this fine to everyone? Tell me. Is this fine to everyone? Okay. In the last class also, we have done these things. which means in the joint PDF or PMF, we were finding out the expectation. Now, let's suppose the joint PMF is given. Okay. Now, instead of function of xy, if it is just a function of x, maybe just x, then can I apply the lotus rule? Tell me. If it is just x, I think yes, right? X is also a function of x, obviously, and also by. I mean, you can say it is into by power 0. Okay. If you are saying how it is a function of by, then you can say it is by power 0. Okay, like that. Anyway, so you can definitely apply the lotus rule. In fact, it is just x, not a function of y. Okay. So if it is in general also you can apply, then obviously for the special case you can apply. Is this fine? Let me know. Okay. Right. Great. So basically it is easy to prove from here also that it is same as summation over x, this x only, and then px. Basically, you can say that, okay, you can flip this x and y, doesn't matter. And then this x you can take outside, and then basically this thing is just marginalization, right? This thing is just px. If you want, you can prove it. Okay, that's easy to prove, not very hard. Let me write xy just for your own sake of, if you want to prove, then you can prove like this. Okay, this is, let's suppose x, this is y. Okay, so this quantity, okay, this quantity x you can take outside because it is constant with respect to y, and then this quantity just px, which is the formula of expectation. Anyway, so you can even prove it. Now, coming to this example here, uh, in this we want to find out, in this we want to find out the expectation of x. So the expectation of x will be summation over all the possible values of x, all the possible values of y, the function, whatever is the function, right? And then pxy. So what is this function? Just x. Okay. So if you sum over all the possible values of x and all the possible values of y, I think, okay, by is not even the playing any role. So I think if you just sum over all the possible value of x, then for x equal to 0, it doesn't make sense. For x equal to 1 only you will be summing, right? So it will be probability of x equal to 1, and for x equal to 1 you will be summing, which means y will be 0 and y will be also 1 plus. Basically, in general, there are 4 pairs, right? Are you getting the point, or should I tell you little more? See what I'm saying? This is this quantity is actually all the possible values of x, all the possible values of y. But this is multiple of x, right? So whenever, so there, here are, you will be getting the 4 pairs: x equal to 1, y equal to 1, x equal to 1, y equal to 0. Similarly, x equal to 0, y equal to 0, x equal to 0, y equal to 1, right? So for 4 pairs, you need to sum. First pair will be 1 into p of 1, 1. Second pair will be 1 into p of 1, 0. Third pair will be 0 into, right, p of 0, 0, something like that, plus 0 into p of 0, 1, something like that. So these will get cancelled out. Only p1, 1, where x is 1, it will remain, right? Okay. So similarly, you can find out ey, and then you can find out exy. So let me just tell you. So exy will be, just using the lotus rule, it will be like this. Ex will be this, and ey will be this. Now let's see how many of you can answer one question. Okay, one easy question, let me ask you. And let's see how many of you can answer that easy question. Suppose this is the joint PMF that is given to you, right? And this is basically, you can say, the formulas that you are getting. Okay. Now just tell me, how many quantities will survive in this first EXY? How many quantities will survive? Whenever x into y is actually 1, not just x, not just y. These are actually summing over all the possible values of x, all the possible values of y. Don't worry, it is two summation. Okay, if it is comma, means it is just a shorthand notation. It is two summation. It's not just one summation. Okay, so there are obviously 4 pairs, but out of them, how many will survive? Only one pair, right? Wherever x into y is 1. Okay, then only it will survive. So basically this whole summation will be P11. Can anyone tell me directly what is this expectation of xy? This is very easy to calculate. Expectation of xy is 0, right? P11, probability of 11. Is this understood? Okay. How many pair here will survive? I think whenever x is 1. So whenever x is 1, y can be 1 or y can be 0. Here, whenever y is 1. So which means whenever y is 1, x can be 0, x can be 1. So what is this P11 plus P10 whenever x is 1? So it is actually the probability of, you can say, uh, probability of x equal to 1. So it is 1 by 4. This is whenever y is 1, it is again 1 by 4, right? Is this understood how we are calculating all of these quantities? Actually, given any PMF or PDF, you should be able to do it. Okay. Maybe it is a little complex initially, but you will be able to do it for sure. Okay. So the final answer is going to be how much? 1 by 16. But minus or plus? See here, the formula says expectation of xy minus ax into ay. So it will be minus 1 by 16, right? So the answer, the covariance between x and y, 0 minus 1 by 4 into 1 by 4 rotation. Okay. Let's see more examples. Probably you will be able to understand more. Okay. Suppose this is the joint distribution which is given. Let's suppose this is the PMF which is given. In the tabular form, obviously they can give the PMF. They cannot give the PDF in the table form like that. Okay. Now, x is taking 2 values, y is taking 3 values. Okay. Now they're asking you to find out the covariance. Can you do it? So covariance between x and y. Okay. So what is the formula? Expectation of xy minus expectation of x into expectation of y. So you can find out expectation of xy. How? You need to sum over all the possible values of x into xy and then x into y, right? So I think you can do it. So x into y whenever both are non-zero. So if x is 0, it will be cancelled out. This whole row, this whole column. I think only over the 3 values you need to find out xy. Okay. Anyway, out of these 3, this probability itself is 0. So over only 2 values. Uh, Sorry, this is not even the value. This is just a sum. So over only one value, which is 0.1 into 100. 0.1 into 100 is this expectation of xy, which is 10, right? So 10 will be here. Why? Because the formula says summation over x into y, probability of x comma y. So whenever x into y, first of all, should be non-zero. So if x is 0 or y is 0, then it will be anyway cancelled out, right? Only possible values are 2. And whenever this pxy 0, then anyway it doesn't contribute. So only this quantity contributes. So basically x into y here is 100, right? Both are 10. So that's why it's 100 into this probability 0.1. So that's why 10, right? So the expectation of xy is coming out to be 10 minus expectation of x into expectation of y, right? So expectation of x here, I haven't calculated. Ajay has calculated. He is getting 2, 5 and 2 as an answer. So final answer is 0. Okay. So let's just see the final answer. Yes. Great. Right. So actually this 0 doesn't mean, if covariance is 0, it doesn't mean that they are independent. We will see this later on. Okay. So we will see this later on. This covariance is 0 doesn't mean it is independent, but it is vice versa. If it is independent, then covariance will be 0. Okay. We will see this. So that's why they are saying, note that here x and y have the covariance 0, but are not independent. It is not always necessary that covariance 0 means independent. Okay. We will see this. Don't worry. So this is one more example where they have given you, x, y, the joint PMF, and then they are asking you to find out the covariance. So answer is on the next page. Can you try this as an homework? Okay. Answer is there on the next page. You can just check if you're getting the same answer or not. Okay. Now let's just see this true false question. So what they're saying, covariance of x comma y, x comma x is basically just a variance of x. Let's just check it. So actually the solution is here. see, instead of y, I just have x. So it is expectation of x square minus expectation of x whole square, which is just a variance. I mean, the definition of the variance of x. So that's why it is, you can say, true. Right? Easy. But it is important to remember that covariance of x, I mean, if you want to find out the covariant bit of the random variable with itself, then it is just a variance. Okay. It is important to, easy to prove, but important to remember. Okay. Cool. So there are some other properties. One of them we have just seen, this one. Okay, there are some other properties of covariance. For example, this property, it is symmetric, obviously, which means covariance of xy or yx doesn't matter, right? Okay. If we multiply any constant, let's suppose c, then you can easily prove it that all of this, like covariance, I mean, all of the terms here are basically of the expectation. Do you remember all of the terms here? So basically, it is expectation of xy minus expectation of x into expectation of y. Can you prove this third property here quickly? Isn't it very easy to prove? If instead of x you have cx, so c you will be taking outside from here also. So from the total you can take c outside. Is the third one okay to prove, or should I prove it? Okay. So actually you don't need to prove these things, but I'm just telling you. Okay, these are the some properties I'm just saying. Okay, again, this covariance of x comma sum of the random variable. Okay, this is also called a linearity, or some people call it bilinearity. Okay, bilinearity. It says that it is covariance of xy plus, you can just do this z separately, which means covariance of x and y and covariance of x and z. You can prove this using the basic and fundamental formulas, but it is not necessary to prove. Okay. Yeah, this is one more formula that we have. It is actually for variance, but we are seeing it as a property of covariance, which is fine. So you might remember that for the expectation, it follows, right? Expectation of x plus y equal to expectation of x plus expectation of y. Is this okay to everyone? For the expectation, it follows. But for the variance, it doesn't follow. Okay, for a variance, if they're independent, then only it follow. Otherwise, it is plus 2 into covariance of xy. Okay, so variance of x plus variance of y is actually this one. This is also important. Okay, remember it. And constant doesn't co-vary with any random variable. So covariance of x comma c is 0. You can easily prove it. Instead of y, if you have c, then it will be the same quantity. So it will get cancelled out, right? Very easily you can prove it. Instead of y, if you have c, then this property is there, right? Okay. So let's do some practice with these properties so that these properties are very handy to you guys, right? Okay. So tell me, is this true? Okay. Intuitively, it seems like it is true, right? So let's do one thing. Maybe I can prove it, but before that, let's just do more questions. For example, tell me, is this true? For one of the variable we have seen, if it is one of the variable, we can take it like this. If there are two variables, then also doesn't matter, right? So this is true. Okay. Why that is true? Because of this property. See, let me also write the properties for you guys so that you can verify. Why this is true? Because of property number 3. Okay. Because of this property, it is true. Let me know if that is understood. Okay. Now, let's just move to the next question. So this is true because of this property. Tell me this one. This is true or false? What do you think? So what they're saying, variance, right? So we know that, okay, this fifth property we know. Now if it is, ax, then if you take a outside from the variance, then it will be a square, right? So I think this is good, this is good. And from the covariance if you take, then it is just the same quantity, so this is good. So that's why it is true. Understood? Okay. Okay. Now let's see the next question. This one. This is little interesting, I think. Okay. See here. Tell me this is true or false. They are saying if this is, let's just assume that to be one random variable. Then can you just unfold it? Okay. This is X, this is Y. I think you can do it, right? So yes, this is true. Now, interestingly, let's just see this. If you just want to fold it, okay, one more time. For example, this is X plus Y, Z plus W. Then is this true? So there's a difference between this and this. What is the difference? See, we have proved that. We have already proved this whole thing, right? We have proved this, or it is easy to see. So we know, okay, we know this. I can say we know this. Now, can you see this? I think, I think here you can unfold it one more time. Here also you can unfold it one more time, right? So this is also, I can say, true, right? So I can say this is also true. Okay. What about this? If they're independent, then what is the covariance? See, if they're independent, then actually this particular quantity you can, or maybe expectation of, let me just write it. If they're independent, then expectation of x into y equal to expectation of x into expectation of y. Okay. So if they're independent, then actually it is zero, right? This then covariance of xy is actually zero. This is for independence. Independence, right? Okay. Now let's see this question. What they're saying, x is number of heads in the first 7 flips, y is number of heads in the first 7 flips, in the last 7 flips. Okay. So x and y, some quantities they have defined. And now they're asking, compute the covariance of x and y. Okay. This is little tricky question. So just do one thing. Just, we will solve it tomorrow. We will definitely solve it tomorrow. But for now, just try your best, okay, to do this question, and answer is on the next page. Just try your best because it is a very good question. Okay. For now, just try. Okay, just definitely try. Don't skip this question, and then you will be able to understand the things more, because the more you practice, more you will get to understand. Okay. So similarly, there are multiple questions like this. Compute the variance. Okay, this is the uniform random variable. So there are multiple questions. Let's just do one thing. Let's solve all of these questions. Okay. In the tomorrow morning class, let's solve all of these questions. So I will put all of these questions this slide right after the class, and then you can try to solve all of these questions. So there are easy questions only, but you just first try. Okay. So yeah, there are multiple questions that I have, and then we will be basically almost finishing up with this topic. But the questions we will be, let's see the questions in the next class. And in the next class, we will be also starting one more small topic here, which is called correlation. Okay, correlation also we will be starting, and then this covariance correlation will get completed. Then we can have one more practice session to do all of this complex concepts, and then we will be starting the next topic, which is hypothesis testing. Okay. Thank you, everyone. So I'm just putting it this slide right after the class. You can just try all of these questions. Okay. Thank you.